All right, so today we're just going through some definitions, and then you'll spend most of the class period doing an activity, but just copy down the definitions as we go. So a polyhedron is basically taking what we did in chapter 11 with polygons and circles, which we'll talk about in the next slide, but making 3D figures. So a polyhedron is a solid, a three-dimensional figure that is bounded, and every single face has to be a polygon. In other words, it should only have straight edges. Some key things that we are going to be looking at in the activity are we're going to be looking at the faces of certain polyhedrons. The face is just the polygon figure that makes up one whole surface. Edges, as you can imagine, are the sides of one of the polygons. Okay? And a vertex is a point where all of the edges come together. What we're going to be analyzing later today is, for certain figures, how many edges are there, how many vertices, how many faces, what's the relationship between all of these things. All right, so the next thing we're looking at is a non-polyhedron. And a non-polyhedron is a solid that has at least one face that is not a polygon. But it can have a face that's a polygon. Basically, it's if you have one curved edge, it's a non-polyhedron, right? So for this particular figure, we're looking at the fact that, obviously, a circle is not a polygon, so that's what makes this a non-polyhedron. We're going to be analyzing the non-polyhedrons quite a bit in this chapter, as well as the polyhedrons. All right. Types of solids that you guys need to be aware of. The polyhedra solids, where you have all straight edges, are prisms and pyramids. Can anyone describe what the difference between a prism and a pyramid is? How you're going to identify which one you have? Anyone see?
Meet it all at one vertex.
Which one?
Pyramid.
The pyramid, yeah. The pyramid starts with a base shape, right? But then that base shape shrinks as we extend up to a single point. On the prism, does that base shape change size at all as you extend it? No, right? So that's the difference between a prism and a pyramid. Notice that the cylinder is very much like the prism. It's just that it has a circular base, which is why it's a non-polyhedra. But it still is that circle does not change shape or size as it extends up. Whereas the cone shrinks until it comes up to a point just like the pyramid. In addition, we've got the sphere, which is just a globe. So you guys need to be able to identify a prism and a pyramid, cylinder, cone, and sphere, and you have to be able to spell it all correctly as well. That will count. Okay? The other thing that you'll have to do is with the polyhedra solids, you will not only have to tell me if it's a prism or a pyramid, but you'll have to tell me what shape the base is. So for an example, I would call this particular prism a triangular prism. You can have a pentagonal prism. You can have a hexagonal prism. This one just happens to have a triangle base, right? How would you define this pyramid?
Square.
A square-based pyramid, or I haven't necessarily marked that all the sides are the same, so maybe a little bit more general would be rectangular pyramid.
Sure.
Okay, but you're looking at the number of sides that the base has. Are there any questions on the types of solids and how to identify each one? Okay. Regular and concave versus convex. So regular means very similar to what it meant on the last section when we were looking at regular polygons. This means that all the faces of the polyhedron are congruent regular polygons. So look here, this is a regular polyhedron because each face is, how would you describe this face? What is it? Pentagon, and does it look regular? And are all of the other faces that same exact pentagon? Yes. I mean, it's kind of hard to tell because it's 3D, but you can see that all the other faces on this thing are also the same exact pentagon. That's what makes this regular. If I introduce squares into this as well, it would no longer be regular because I'd have two different shapes going on. Even though a square is regular and the pentagon is regular, those are not all congruent shapes, right? Concave means basically the same thing that it did when we looked at the polygons. Remember I told you guys that you could see if a polygon was concave if it could hold water if you flipped it a certain direction, right? Notice here, it's pretty easy to see that these faces can hold water. That's what makes this concave, is that you can flip it some way so that one of the sides can hold water like a bowl. If a polygon is not concave, then just like before, we called it convex. So those are not new words. They have basically the same meaning as we did when we looked at regular polygons. All right, now we have what we call platonic solids. These are 5 special polyhedra that you guys need to be able to tell me what shape each face is on that particular platonic solid, how many edges it has, how many faces, things like that. I'm going to give you the information for a dodecahedron and an icosahedron, but for the top 3 there, you should be able to kind of count how many faces, edges, and vertices it has just by looking at it if you know what the general shape is. So notice that a tetrahedron is a pyramid with what kind of a base? Whoops, I'm about to lose it. Hold on, I'm going to go back. Okay, it's got an equilateral triangular base, right? That's your tetrahedron, but it's a pyramid with a triangular base that's equilateral. And then all of this, you're assuming that all of these faces are also equilateral. Notice that these are 5 regular polyhedra. So we're assuming that all of the faces are the exact same shape and size. The cube, it's just like a dice. The octahedron, again, has equilateral triangles. So you'll notice that there's more than one way for me to make a regular polyhedron with an equilateral face, right? So here's one where notice that the pyramid that's being formed has a square base, but then I'm also not only doing a pyramid on top, I'm extending the pyramid out to the bottom as well. So that's the octahedron. Okay? The dodecahedron. What kind of faces does a dodecahedron have? Pentagons. Yep. The dodecahedron has pentagons. How about the icosahedron? That's another one with isosceles triangles. So you'll notice that you've got 3 shapes here that are regular with isosceles triangle faces. Like I said, those top 3, I assume that you can count the number of faces, edges, and vertices on those pretty easily. I'm going to give you the information for the dodecahedron and the icosahedron, though. The basic information. Okay, so for the dodecahedron, you'll notice that you've got, if you were to count them, you've got 12 faces. I'm going to represent faces with an F. You've got 20 vertices, and you've got 30 edges. Okay, for the icosahedron, you have 20 faces, 12 vertices, and 30 edges. Okay? What you guys need to be able to do is if I say tetrahedron, you have to know like the general shape that it's making. You have to be able to kind of say, oh, that's the one that has a triangular base, it's a pyramid, it's got 4 sides, yada yada. Which 2 are the ones that you think people switch up the most?
Wait, what?
Which 2 of these 5 do you think people like confuse the most about being each other, that they think they switch them up? Octahedron with tetrahedron. Yep, most people will switch these 2 somehow, okay? I am not ever going to make you sketch a dodecahedron or an icosahedron, but you need to know information about it, like this information, okay? A cube, I assume you know that already. Between these would be the 2 to know how to sketch right here. Okay? These two I won't make you sketch, but I will make you know the information. Any questions on that? Okay? So last but not least, we've got cross sections. A cross section is basically if you took a bandsaw and cut through the figure, what shape do you form? So what shape is this cross section? Hexagon. Now, if I cut the shape, picture if I took my bandsaw and I cut it vertically. Am I still going to get a hexagonal cross section from that?
Nope.
What shape am I going to get if I cut through this? Assuming that I've got straight across like this. It's going to form a rectangle, I think, right? If you cut through it like this, it's going to go want, and then you're going to have a piece straight across the bottom, right? And then straight up, and then straight up across the top.
Looking at it from above?
Even looking at it from above, you could get, yeah.
I'm so confused right now.
If I cut straight through this, right? Then you have a flat edge on the top, right? Straight edge down the side. Flat edge on the bottom, straight edge up the top. So that piece all together forms a rectangle. Do you see what I'm saying? Okay.
Cut it straight in half.
Nope. So you can see that depending on how you cut a figure, you can get different cross-sectional shapes. So make sure you're looking at how they're cutting it. Are there any questions on any of these definitions? Okay. All right. So we've got an in-class activity today. You guys are going to have to move through this pretty quickly. You're not going to have time to diddly-daddle. It's going to take you the whole period, and you're going to have to move, okay? Once you're done with that, this will be your homework. Everything that you do in this will help, or do here is going to help you with this. Got it? Okay, I'm going to come pass out. You can start reading the back. Hold on, did I pause it? Yeah. One thing you guys will notice, if you look at the activity on the back side, it is going to be easy for you guys to fill in the edges, faces, and vertices without constructing some of them. I get that. I still want you to construct these because especially with those platonic solids, a lot of you guys are going to forget what shapes those are, and actually building it will help you kind of connect with it, right? You'll remember kind of putting it all together. So while I know that you can just, like, when you get to the tetrahedron, I understand that you guys can flip it over, look at your tetrahedron, and count up everything on that, like, picture. Please don't do that, just because building it is going to help you make sense of what's actually happening in that. Does that make sense? I'm going to be walking around, and if I see you just sitting there filling in the chart, you're not going to get credit. Got it? I do want you to actually build these things. Okay, can I have somebody come around and start passing out toothpicks about this many per person?
Got you.
Thank you. I actually have 2 people doing that.
Actually love doing this.
Did you see how many I said?
No.
So it should be about that much.
Chunking.
Yeah.
Chunking. That's crazy.
Yeah? Yes. Hey guys, I'm going to give you gummy bears. You are not allowed to eat the gummy bears until you are done with the activity. If I see you eating gummy bears before you're done, you do not get credit. Okay? When you're done, then you may eat them. You will have to take apart some of the figures before you rebuild. I'm not giving you enough to build all of them at once. You can work with your partners, you guys, so you can divvy them up. Like, let's say when you're constructing, like, have tie build.